Hey, folks. Okay. So today I want us to continue with trig equations. I will continue with more questions from Timadas. Yeah, so please take out your calculators, your pens, and your papers because we'll be solving a lot of questions. I think I'll give you only 5 questions today. Just 5. Okay, sharp. So these are the questions, folks. So solve each of the following trigonometric equations in the range given. Now, what I like, or what I would suggest is that you pause the video, attempt these questions on your own, right? Try them on your own, and then you can then play, right? You can then continue watching the video. Sharp. So, okay, let's start moving. Okay, remember there is part 1 of this of these videos where I explain what trigonometric equations entail, right? So please go and watch that if you don't have a clue as to what we are talking about here. Okay, so I'll start with this one, with A. So here, first thing, guys, remember the first thing is to look at my trigonometric function. My trigonometric function here is equals to -1/2. Now, the fact that my trigonometric function is negative, it means if I look at my CAS diagram, I'm looking at quadrant 3 and quadrant 4. Now that's going to be important. So that's the first thing. The first thing is to determine which quadrant you are dealing with. Okay, now that I'm done with this, then I'll look for my reference angle now. So to look for my reference angle, I use the arc of, remember, we just take the positive value. So the inverse of half, that is 30 degrees. Remember, you can check that with your calculator. So that's my reference angle. As soon as you find your reference angle, you then say, okay, I have x is equals to, because I'm dealing with the quadrant where sine is negative, it means now that is going to be 180 plus my reference angle plus k 360 degrees. And you also have 360 degrees minus the reference angle plus k 360, where k is the element of integers. So why k 360? Because that's the normal period of a sine function, right? So what we have here, we have x is equals to, that's 210 plus k 360, and that's 330 plus k 360. Okay, so what we have now, this is what we call our general solution. But in this case, we're not looking for a general solution. We're looking for particular angles, right? That will satisfy, that will satisfy the equation given. So those angles must be between 0 and 360 degrees. So it means now I must substitute integers where there's k. Yeah. So I hope you can see that if I substitute a negative integer where there's k, so I'll get 210 minus 360, I'll get a negative value. Same applies here. So it wouldn't make sense to substitute k equals to a negative integer. So I'll just try k equals to 0. Right, then if I do so, I'll have 210 plus 0, and this side I'll have 330 plus 0, because I'll have 0 times 360, 0 times 360. So you can see that my solution is actually those two angles. It's 210 and 330 degrees. So those are my two angles, right? Tango. At least we get B from das Mambi. So our B, we have cos 2x equals to negative 0, 1736. Now we are given that our angles should be between 0 degrees and 360 degrees. Okay, first thing first, to look for my, okay, again, first step, observe your cast diagram. Cos is negative, negative where? In the second quadrant and the third quadrant. Okay, sharp. Then we look for our reference angle. So we look for reference angle. Okay. Cos, inverse cos of 0.1736. It's 44,47, right? 47 degrees. Okay, so that is my reference angle. Then from there, we then say, okay, we have 2x is equals to, we said cos is negative where? In the second quadrant. So it's 180 minus my reference angle. And this side is going to be 180 plus the reference angle. Yeah. I think I made a mistake somewhere. Yeah. So in my calculator, I only used 7136 instead of 17. So the reference angle is 80.3. Yeah. 80.3. Okay. So 80,13 degrees plus K 360. Because again, the normal period for cos is 360 as well. So from here, I'll then say 2x is equals to 180 minus answer. So that is 99.87 degrees. Right, plus K 360. This side we have 260 plus 13 degrees plus K 360. Sharp. Then divide everything by 2, 2, 2. Therefore, my x now is equals to 49.93 plus K 180. Here, x is equals to calculator 130.07 plus K 360. Ja, where K is the element of integers. Okay, so if we were looking for the general solution here, you would stop. But that's not what we're looking for. We're looking for angles given that range. Nah. So here, the first thing that I'll do is to check for K equals to, let's check Z. Nah. I'll start with K equals to 0. Now, if I have K, all right, no space. If I have K, if I substitute K equals to 0, I'll have X is equals to 49.93 degrees here. And then there, it's X equals to 130.07 degrees sharp. And then, with that being said, now let's try K equals to 1. So I'll have X is equals to 49.93 plus 180. And here, X is equals to 130 plus 360. Now you can see this one won't work because we are beyond 360 degrees. So I'm left with this one, which is 49.93 plus 180. Yeah, it's 229.93. Okay, sharp. So we have 1 and then 2 and 3. Okay. This was supposed to be 180, not 360. What's wrong with me today? This is supposed to be 180. So that here we have 180 degrees. Yeah, now it makes sense. So now let's check. (180.07 plus 180 degrees. Aha, we get 310.07 degrees. Okay, so now my angles, I have 49.93. I have, and then next one, I'll use 130.07 degrees. In the following one, 221.93 plus 310.07 degrees. Yeah. Those are my four angles. Nah. Those are my four angles. Okay, sharp. Then let's look at C. Ucabanga. Change my pen. C. Add 10. X minus 40 degrees equals to 0.7. Between 180 degrees, X, and yeah. Okay, first thing first. Look at your cast diagram. Where is tan positive in the first and dead quadrant? Tango. And from there, let's move. We look for our reference angle. Now, what is the reference angle? Arctan or inverse tan 0.7 is okay. 30. Well, this one, can I just make it 35? Because it's actually 34.99. Yeah, let's just round it off to 35. So that is my reference angle. Okay, now that I have my reference angle, then the next step is to then say, okay, I have my reference angle. Tan is positive in the first quadrant as K. Now I'm not using 360, I'm using 180. Then X minus 40 degrees is equals to 180 plus 35 degrees plus K 360, K 180, where K is the element of integers. Now, okay, so X equals to, take that to the other side, then it becomes 75 degrees plus K 180. This side, we have 180 plus 35 plus 40, 255. Sharp. That's the general solution. If we're looking for the general solution, then here you can stop. Fine, no problem, no stress. But now I must start substituting. So because now negative angles are also allowed, let's look for K equals to -1 and see what we will get. X is equals to 75 minus 180, and then X equals to 255 minus 180. Okay, what we have? This should be -105, and then here 75 degrees. Massive. Then K equals to 0 now. So K equals to 0. We have X is equals to just 75 degrees. This side and then that side, I'll have 255. And here, okay, sharp. So with that being said, let me see. I have So if I substitute k equals to negative 2 there, 250 minus 360. Okay, yeah, I think those are my angles. So x is equals to x is equals to negative 105 and 75, then 255. Yeah, those are my angles there. But we have a problem because if we go back, they said here x must be less than 180 degrees, and here that is greater than. So, which means my answers will only be this. So I won't include this one. So I'll only have. But it's important to always go back to your restriction. So I'll only have those two. Negative 105 and 75. That's all, nothing else. Yeah. And then that's the solution. Okay. D. I have sine 2 beta plus 40 equals to 0.9848 on 80 degrees. Okay. First thing first. First thing first. Sine, whatever angle is positive. Where is sine positive? In the first and second quadrant. Sharp. After establishing that, we then look for our reference angle. So inverse sine of 0.9848. Okay, so what is that equals to? Inverse A. Inverse sine 0.9848. Okay. It's 79,997. I'll just make it 80 degrees. That's all. 80 degrees. So that is my reference angle. And then as soon as you get your reference angle, you then say, okay, that equals to my reference angle plus sine k 360 degrees. Then again, we have 180 minus the reference angle now. That's the second quadrant. 60. Sharp. Where k is the element of integers. Then from there, simplify. 2 beta equals to take 40 to the other side. I'll have 80 minus 40 is 40. And then 2 beta. 180 minus 80 is 100. Minus 40 is 60. And plus k 360 degrees. If k is the element of integers, then I divide everything by 2. Therefore, beta is equals to 20. plus k 180, and then theta is equals to 30 plus k 180 degrees. Sharp. So this is what you have. So again, that is your general solution. But we're not looking for the general solution here. So we must do what? We must substitute. We must substitute. We must substitute. So again, I'm looking for angles between negative 180 and 180. So I'll start by checking k equals to negative 1. That is theta equals to 20 minus 180. Here I'll have theta equals to 30 minus 180 as well. So that is negative 160 degrees, which is beyond. And then here we have negative 150. Okay, sharp. Then let's try k equals to 0. So for k equals to 0, theta is equals to 20 degrees. Here theta is equals to 30 degrees. All right. So what are we having here then? We have 20, we have 30, we have negative 150, and we have negative 160. Is negative 160 in the range? Yes, it's in the range because negative 160 is actually bigger than negative 180. So it's in the range. Therefore, our theta, so we have 4 angles that will satisfy our solution. We have negative 30, we have 20, we have 30. Sharp. So those are your 4 massive angles. And then, with that being said, last question is E. Of course, 4y minus 60 equals to root 6 minus root 2 over 4. Y 90. Okay, again, first thing first, cos is positive. Cos is positive where? In the second and in the first, I meant, and fourth quadrant. And then from there, you look for your reference angle. Okay, let's check. Inverse cos of root 6 minus root 2 over 4. Massive, 75 degrees. So that's my reference angle. What does that mean? It means I have 75 degrees plus a 360. Then I have 360 minus my reference angle plus k360, where k is the element of integers. So 4 is equals to 135 and 4i equals to 360 minus 75 plus 60. It's 3, 4, 5 degrees plus K 360. Okay, is the element of integers. Then divide by 4, divide by 4, divide by 4, 4, 4, 4. Y is equals to 4 goes into 13 3 times. Remainder is 1. Oh, problem. 33.75 plus K90 918.736. Then Y is equals to 345 divided by 4. 86.25 degrees as K90. Okay, again, if we're looking for the general solution, you would have to stop here, but we're not. I'm looking for angles between 0 and 90. So it makes sense to then substitute K equals to 0. So I'll have Y equals to 33.75. Here Y equals to 86.25 degrees. Sharp. So those are the two solutions, 33.75 and 86.25. Sharp. All right, folks. That's all, nothing else. Thank you so much. Please like and subscribe. I'll see you in part 3.